All right, in this video, I'm going to show you how to put together this image of Messier 7, an open cluster. Very pretty. Okay, I've already made my stacks. So I collected data mostly with the Prompt 5 telescope in Cerro Tololo. It's a 16-inch diameter telescope. The camera is only 1K by 1K, so kind of smaller images. I collected data in B, V, and R, kind of the standard filters that I use for color combination. They match the human eye fairly well. But I was also experimenting with using filters other than BVR. So I also have stacks of G prime, R prime, and I prime. These are Sloan filters. They're all about half a filter redward of BVR. And for all of those, I got 9 images in a dither pattern, 10 arcsecond spacing, and each frame was 20 seconds in duration. Okay. I also got some luminance data. Now we can see it here. And for this, knowing that luminance, would be brighter, I took 10-second exposures. I took twice as many, 18, 20-second exposures, same dither pattern. Now, as you can see, I saturated on the bright stars. This one's really apparent, and if you change the stretch, you can see their saturations under the other bright stars. So at first I was like, oh, bummer. Actually, I got these saturation bleeds on almost all of them. So instead of reshooting everything, I was going to just reshoot the luminance. When you combine a luminance frame with your color image, you take the intensity from the luminance frame, the color from the rest of it, so you can correct a lot of mistakes with a better luminance frame. So my plan was to use the slightly saturated color images, but to get a clean luminance filter. And I put it in. I was kind of in a hurry, so I said any telescope. It didn't have to be Prompt 5. I'd take any of the Chilean telescopes. And this time I did 36 exposures. They would have been 5 seconds on Prompt 5, but they went through on Prompt 7, which is our 32-inch. And since it's bigger and more sensitive, Skynet compensated, and they were slightly longer than 3-second exposures, 3.3 something second exposures, I believe. And I combined those, and they weren't saturated, but I noticed that the diffraction spikes, here you see Prompt 5, its diffraction spikes are on the diagonal. Prompt 7's diffraction spikes were up, down, left, right. They didn't line up with these diffraction spikes. But so it'd be a little weird. The color images have diffraction spikes on the diagonal and the luminance on the plus minus. But I thought I'd just combine the luminance data from Prompt 5 and the luminance data from Prompt 7. The diffraction spikes on Prompt 7 will line up not with these diffraction spikes, but with the saturation blur. And so this is what that looked like when I combined all of those images. And yeah, you still see a little bit of the saturation, and it shows more once you change the stretch mode. But it's hidden fairly well by the Prompt 7 diffraction spikes. And I kind of like the 8-prong diffraction pattern. I thought that was something different. So decided to run with it. Okay, let's put these together. I'm going to select them all except for that first luminance frame. I'm going to use this one instead. I'm going to group them. Give it a second to do the group. Okay, there it is. And it put the luminance up top, and that's good. If it's somewhere lower in the list, be sure to move it to the top, and just by dragging it up. Now let's set everything. The luminance frame, you want the color to be gray, blend mode to be luminosity. And then for your individual images, B will be blue, and the blend mode on all these others is just screen. That's the normal one you want. Let's see, B is blue, V is green, R is red. Just check those. Yep. And G prime is going to be blue, R prime is going to be green, I prime is going to be red. Let's check those. Okay. Right now, everything's turned on. And so here is everything put together. And the default, it says manual, but manual just is when you're in one of these other modes and then go to manual, it keeps whatever you had done. Since we're just starting, it actually defaults to percentile and then puts it in manual mode. So it's in percentile mode. Okay, let's start by the normal BVR combination. So I'm going to turn off the G, the R, and the I. And missed the G there. G is off. Okay. So, and actually, I'm going to turn off the luminance filter right now as well. And we're just going to do the combination, the BVR combination. And so to do this properly, percentile is not the proper levels. We are going to go to histogram fitting, and we're going to do, we can actually reset the histogram to the original levels. And yeah, that's what it'll look like when you start out. I had already been messing with the settings, so I just set it back there. Photometric color calibration. So select B, select V, select R. I'm going to measure those 0 points. And it looks like it updated the color. Sometimes that's a little slow. So when I went back to the default, you saw the histogram spread out, and it has to update each subframe before it can update the combination. It just did the combination behind. And you can already see it's very red because this histogram's to the right. We're going to correct those levels. And so we're doing catalog. From each frame, we're source extracting, comparing to catalogs, getting the 0 points. That sets the levels. Reference layer doesn't really matter. I'm going to let it be my bluest layer. And white balance, it's set to black body peaking in B, and that's how the human eye works. The human eye sees black bodies, a thermal spectrum that peaks in the B filter as white. And so that's set like that. And well, let's just start with that there. I'll calibrate the colors. There we go. Maybe I'll use the default preset for starters. Okay. Now there's dust between us and M7, and you can look it up. I look it up on WebDA. And let's see if this is, I think that's, yeah, this is M7. NGC 6475 is M7, and you can see the reddening is 0.103 here. So I'm going to go back here, and I'm going to de-redden the dust. There's dust between us and M7, and I'm going to take it out. So when I press this, it should get got just a tad bluer. And you may have noticed there's a button pressed here, neutralize background. And so the catalog calibration gets the stretches right in the histogram, how much they're scaled left, right. But then you can have a shift, and we shift and line up the peaks, and that gives you a nice neutral background as well. Okay, so it's a good start. It's the color component. But I'm experimenting with G prime, R prime, I prime. So let's see what that looks like. I'm going to turn off the BVR, turn on G prime, R prime, I prime. There we go. And we're going to calibrate that. I'm going to set this to G prime, R prime, I prime, going to get new 0 points. Our reference layer will now be G prime. Same extinction. Oops, sorry. G prime, there's the reference layer. And the white balance, you can change it to G prime, right? If we're imaging in BVR and have a white balance of black body peaking in B, that's natural color, or as close to natural color as we can get. But what if the human eye instead worked in G prime, R prime, I prime, with the black body peaking in G prime, giving us a white color? And we can calibrate this. And what it does, maybe I'll hit default preset here, change the brightness and contrast a little bit. What this does is it doesn't give natural colors. G prime, R prime, I prime, they're all shifted by half of a filter towards the red. So everything is shifted by by half of a spectral class. The colors are too red by half of a spectral class. You can compensate for this by moving the white balance another half of a spectral class. So if I come here, G prime is between B and V. So if I take black body peaking in V, there we go, this should blueing it up just a tad. You may have seen that. It's really subtle, but this restores natural colors. If you print all these out and compare them, the blue of the stars in G prime, R prime, I prime with black body peaking in V is very close to what you get from BVR with black body peaking in B. Okay. Now, one difference when you go to G prime, R prime, I prime, since these filters are farther to the red, the stuff that's obscured by dust will be brighter. Since we're redward, dust has less of an effect. So the reddest stars will be brighter. And that's something you may have also noticed. The red stars got a little bit brighter and they stand out more. And I kind of like that. The BVR colors were kind of dull. Other than the blue stars, which are kind of pretty, the rest of the colors, kind of what you see in globular clusters, just kind of different shades of beige, and I find it kind of dull. So going to G prime, R prime, I prime, I got this kind of pleasant surprise where the reddest stars popped just a little bit. Okay. But, again, I set the white balance to still keep natural colors. It's just the red stars are a little bit brighter than what the human eye would see. Okay, now we're going to set the luminance layer. And you notice I didn't really mess around with the brightness and contrast on the color layer because it doesn't matter. Once I activate that luminance layer, it's going to take the intensity from the luminance layer. And so we don't really have to fine tune the stretch mode and background and saturation levels in the color layers. You can just leave them as is. I'm going to turn on the luminance layer and let's tune it. And so I'm going to double click on the composite that locked it in, double click on the luminance layer, and I'm going to split right. Maybe I'll hide this over here, get a little bit more space. Okay. And first I click on the composite and I'm going to set it to manual mode. So I keep all the stretches and shifts and everything of the color layers, of all the layers. But now I can tune them. And I'm going to, again, I'm not going to worry about the color. I'm just going to tune the composite. Okay. We want to move away from linear. Linear, log, square root, hyperbolic, arcsine, all those things leave the bright things really kind of saturated. Not technically, you haven't filled up the chip, but just kind of blowing out in the image. So that's why we added this mid-tone. Now, you first click on it, looks like crap, but you gotta maybe press default to start. And this is nice, right? We're no longer blowing out the stars, and we can tune this a little bit. You have a background level, you have a saturation level, and there's this mid-tone level. It's basically a single control point for those who use PixInsight or Photoshop or something like that. It's a single control point that you can move around. And I like using the percentile mode. I'm used to thinking of things that way. Now the saturation level, you normally don't need to change it. It's right at the top of the chip, or almost at the very top, 99.999% of the way through this distribution. The background level, you gotta take some care with that. A lot of people say you move it right to the peak. And let's see what that would look like. If we go up to 10% of the way, 20% of the way, 30% of the way, it's just, right below the peak is what they say. But what you've done is you set 30% of your pixels to pure black. And so if we zoom in here, the bottom of the image looks kind of crappy. Just pure black, no texture to it, and then some stars pop up above the noise. So I'm not a fan. So let's come back here and let's put it back at 1%. See how all those stars pop back in? Here, I'll go to 30. It's very black, and then back to 1. See all that detail popped in at the bottom of the image? At least in some layer, whether it's the luminance layer or some of the supplemental layers that we put above, you're going to want the background to come down to a very low percentile, so you have texture in the bottom of your image. And I'm going to do it here in the luminance layer. So I think that looks pretty good. And then you adjust the midtone. It's at 97.5. We can try 99. Okay, that dimmed everything too much, in my opinion. Maybe 95. Kind of like that. 90. Okay, so I'm starting to, it's getting too bright. Those blue stars getting too bright. Let's go with 95. It's maybe a little higher than if this were at the end and we were just going to go with this. I'd probably tune them down a little bit, but we're going to throw some other stuff in, and they're going to need to stand out with respect to the other stuff. Okay, so that's a good start. And if you're just doing optical, it's a finish. You've done it. Let's get our layers back up here. But I find this, I don't know, let's get rid of this one. It's a little blah. I mean, the blue stars are pretty, but the rest is kind of speckly, and we got the little pop of the red stars, but got a lot of the boring beiges back there. And so I'm going to supplement this in the infrared using Weiss data. It's a trick that I've learned, and I really like the effect. So let's go to Skyview Virtual Observatory. Query form. We're looking at M7. And for things with common names, it knows the coordinates, so you don't have to look them up. And it has everything from gamma ray to radio. And a lot of this stuff is, particularly like in the radio, the blurring scale can sometimes be like a degree. And that field of view that we're looking at is 1/6 of a degree. So, you have to pick your things wisely. Here's the Weiss spacecraft, infrared. And at 3.4 and 4.6 microns, you're still seeing stars. But once you get into 12 and 22, what you're seeing is warm dust. And that's really kind of interesting if you're looking at a dusty region. And you may not be able to tell, but it's a star-forming region, a young one. You can tell from the blue stars that it's young. And so there's got to be dust around here. In other images, you can see dust laying, like if you have an emission nebula, it brightens a whole region, then you can see the dust in front of it. We don't have any emission nebulae here, so you just gotta have to trust that there's dust. But let's find out. Let's find out. And so let's start by grabbing the 12 micron data, though we're actually going to grab both 12 and 22 in time. In projection, I really don't know. Probably this is fine, but I always set to rectangular. right ascension on one axis, declination on the other. For a field of view this small, it probably doesn't matter, but that's what I've done in the past. And then you got to pick the image size and in degrees and pixels carefully. This is prompt 5. So let's go to Skynet and take a look at the prompt 5 information. Sarah Tololo, prompt 5. I mean, there's a little bit of prompt 7 in the luminance filter, but prompt 7 is a big field of view, and we scaled it down to the prompt 5 data. So prompt 5, it's 10 arc minutes across and 1024 pixels across. So we don't know if it's centered exactly the same, this data I'm about to grab, if it's centered exactly the same as the data you have. So I like to grab a larger region. I just up the numbers by 50%. So instead of 10, it'd be 15, but that's arc minutes. This is degrees. So 15 arc minutes is 0.25 degrees. So instead of a sixth of a degree, I'm going to get a quarter. And the pixels, it was 1024, but 50% bigger means 1536. So this keeps the same size pixels. Okay, I'm going to submit the request. It takes a second. It's resampling, rebuilding this image, but it will pop up here. It will, I swear. Here it is. Okay, so here it is, and we can save it as a FITS file. And while we're here, it's downloading. It's going to take a little bit of time. Let's get the other one. So we come back here. You got to clear the survey selections. I'm going to get Weiss 22. So it's farther into the infrared. It's going to be a little bit blurrier, but it's kind of like a nice layer if you use it with a light touch. And so same everything here, submit request. So we'll go grab that one. This one's come in. Here it comes. You can see it's blurrier. And grab that FITS image. Okay, it has about 20 some seconds. Let's go to Afterglow. You can go to Open Files. I'm in my workspace, gotta be in your workspace, and we're gonna upload this data. And here they are. I'm gonna just grab both of them. Okay, completed, close. And they should be down here, this one and this one. And they're just numbered sequentially. And so it's always the last ones. I'm gonna open those. Okay, now I'm gonna group them. I'm gonna add them to the group. So click on the group first and then these guys. And group selected files. Okay. Bring the group up here. You can see they have histograms that are like in crazy places. I'm going to turn these layers off for starters. And I'm going to slide them up above the luminance layer. That's important. Okay. Because, you know, the luminance layer, if we let that determine the intensity, then whatever we just brought in the infrared, it will be suppressed, you know, away from the bright stars. We want this to layer on top of the bright stars because it's going to be something different. The G prime, R prime, I prime, that's all, you know, acquired in the same wave band as the luminance filter. So you have that underneath. But this infrared supplementation, you stick that over the luminance filter. Okay, let's turn on probably this one. Let's look at it here. Still loading in. And I like to color the infrared using the heat map. Okay, maybe we'll color this one too. Color map, heat. And let's take a look at it. It's loading in. It's broader. Okay, and it's in here, but it's all messed up because it's the wrong size and the wrong orientation. We have to align it, and then everything will be in the right place. You know, it doesn't look right. So go to the aligner, and we're going to select those two frames, and let's see, it doesn't really matter. They're all the same, but I'll just align it to the G prime. That was my reference layer. So I'm going to align those two and this one, reference image G prime, submit. And I think the infrared layers are rotated and stuff like that. So this should fix it all up. And look, it's updating. There we go. Now everything's where it's supposed to be. If I turn it on and off, you see this really cool thing. See the bright red stars, the stars that we got to pop a little by going to G prime, R prime, I prime. They're red because they're behind a lot of dust. And not just line of sight dust. You know, this is a star forming region. Some stars are still embedded in dust. And those stars are heating the dust around it, and it glows in the infrared. So all those bubbles are right where the red stars are, which is really kind of cool. It's exciting. But we got to set the relative intensities correctly. So again, we're going to double click on the stack. Oops, that was the luminance. I didn't use the stack. Let's get rid of that. And let's double click on this first infrared layer. Split right. Hide that and fit to zoom. Okay. Going to go back up here to display settings. Still on manual. And for here, I'm going to set this to midtone. And maybe start with the default. Way too bright, way too bright. Let's dim it down. Let's go to 99. Actually, before we play with that more, the background here, I don't need this layer to go all the way down and fill in the dark areas. We did that with the stars. So let's set our background to right below the peak. There's 20%, 30%, 40, maybe that's too far. Let's go back down to 30. Just a little bit below the peak. Okay, that's good. And let's see, the default here is 97, oops, get this right, 97.5. It's reading too quick, 97.5. And to me, that's a little bit too much. The infrared's too much, so I'm gonna crank it up a bit, 99, maybe 99.5. Yeah, that's kind of nice. 99.9, yeah, way too faint. It's not enough. 99. Did it again. 99.5. Let's try that. I think that's what I used before. If not, we'll tune it a little bit. Actually, I probably used 99. Yeah. I think I used 99. Okay, and that looks pretty good. Looks like, I don't know, when they light those lanterns that float in the sky, it has that kind of feel to it. I like that. But let's tune it just a little bit more. Let's play with this other layer. I'll bring it up over here. This is the Weiss 22. I'm going to turn it on. Initially, it's, again, way too bright, so we're going to tune it. We're going to go to midtone and the default. And let's get that background up to the same kind of 30%. just below the peak. And the last one was 99. If I make this 99, it's a bit too much. I just want this to be kind of a gentle, it's a light touch on the infrared. So let's go up a little bit higher, 99.5. That's good. If I go up to 0.999, it's like essentially gone. So I bring it back down, 99.9, it's barely there. Not even worth doing. So maybe 99.5. See how it just kind of fills in the spaces between the warm dust bubbles a little bit, gives the image some texture, some flow, instead of just being points of light here and there. Okay, and that's it. I think that's the image. Let's take a look here. I think that's this. Yep, nailed it. Okay, and then be sure to print it out. Not that, that's just a screenshot, but this captures every pixel. And here it is. Voila.